Welcome back to the Explainer. Today we are locking in a rock-solid concrete baseline for the Latorno Super 116 E-Class jacking systems. And specifically, we're looking at the 3-leg, 5-high inline EU configurations. This is built strictly for you, the offshore engineers and technicians on the ground. By the end of this run-through, you're going to be pulling critical torques, clearances, and tolerances right out of your head and diagnosing common faults without missing a beat. So let's dive right in and get these numbers locked down. But hey, before we look at a single number, we've got to hit this absolutely critical disclaimer. You must always consult your vessel-specific IOM manual before doing any actual work. What we're going over today is a fantastic reference, but your rig-specific manual, that's your ultimate authority. Safety first, every single time, no exceptions. All right, so here's our game plan for today. We're kicking off with a rapid-fire critical measurements drill. After that, we'll branch out into troubleshooting mechanical faults, brake system faults, and finally, electrical and PLC faults. Moving into Section 1, Critical Measurements Drill. Now, let's see if you can actually anticipate these values before I even say them out loud. First up on the drill, 0.070 inches, which is 1.8 millimeters. That right there is your operational brake air gap. Seriously, commit this one to memory. It's basically the heartbeat of a healthy braking system for your jacking operations. Next up, we have 150 foot-pounds plus or minus 5. Now, this is the exact motor retorque required after you do a brake pop. It's a really precise window, and hitting it dead on is absolutely crucial to guarantee the integrity of that motor assembly after high-stress testing. Moving right along, 170 foot-pounds. That's your brake lock bolt torque. But wait, remember the absolutely critical modifier here. That bolt must be grade 8, and it has to be installed completely dry. If you add even a single drop of lubrication to that, your torque values are going to be completely thrown off. Okay, 0.3 degrees. This is the absolute maximum hull inclination limit you must adhere to, period. If you push past this limit, you're placing immense unintended shear stresses on the legs and guides, and frankly, the 116 E-Class structure is just not built to handle that. Now let's look at a consolidated cheat sheet for the remaining clearances and torques. Notice the incredibly tight tolerance on the number 4 gearbox output pinion end play. We're talking just 0.001 to 0.003 inches. Super tight. Also, look at how the backlash scales up depending on the pitch. You really got to pay special attention to those hub bolt torques. 1,363 foot-pounds for the quarter pitch and 500 foot-pounds for the half pitch. And hey, unlike that brake lock bolt we just talked about, both of these absolutely require lubrication. Lastly, keep in mind that while your operational air gap is 0.070, your absolute maximum bench setting is 0.090 inches, or 2.3 millimeters. All right, let's test your short-term retention right now with a quick scenario. Imagine you're out on the rig, you're checking the brakes. What is that operational brake air gap specification actually supposed to be? Is it A, B, C, or D? Take a second and lock your answer in. Okay, the answer is C. The crucial point here is that 0.070 inches is your healthy operational baseline. Now, if you guessed A, 0.090, remember, that's your absolute maximum bench setting, not your everyday operational target. Moving on to Section 2, Mechanical Faults. We know what the baseline should be, so now let's talk about what happens when that baseline actually fails. So let's trace some top mechanical symptoms right back to their causes. If your contactor won't close, don't overcomplicate it straight out of the gate. Check the e-stop first, look for an auxiliary contact fault, or check your circuit breakers. Remember, all 3 breakers must be closed for the jacking controls to even be enabled. Now, what if multiple motors overload on a single leg all at the same time? Well, then you're looking at a macro-level issue. You should immediately suspect severe leg guide wear, excessive physical friction, or worse, a total leg lubrication failure that's affecting all the drivetrains on that one leg. But what if it's just a single motor overloading while you're jacking? Well, then you need to follow this exact chronological order of diagnosis. Step 1, briefly bump the motor. Is the brake actually releasing? If it is, move to Step 2 and investigate the motor current draw. If that looks normal, move to Step 3 and check for physical gear binding. And finally, Step 4, check your pinion and bushing lubrication. I promise you, following this exact sequence is going to prevent you from tearing down an entire gearbox in the pouring rain just because a stubborn brake didn't lift. All right, Section 3, Brake System Faults. Let's follow that kinetic chain downward and see how this builds into brake-specific troubleshooting. So you're doing a pop test, and the brake just straight up refuses to release. Here is your symptom to cause framework. Step 1. Keep the brake energized and gently tap those discs. Sticking is incredibly common out there offshore. Step 2. Watch the pressure plate. If it retracts but just won't unwind, your discs are physically stuck together. Step 3. If it doesn't retract at all, grab your multimeter and test the voltage right at the receptacle. You might literally just be looking at an open circuit or a loss of power. Step 4. If it fails every single cycle, even though it has power, you've got to suspect warped discs or damaged springs. At that point, it's time to replace the brake. Moving to Section 4, Electrical and PLC Faults. Now we're shifting gears from the heavy physical machinery to the digital brain of the whole operation. These are your absolute most critical electrical reads. First, for a ground fault on the GFR, you want to isolate it by disconnecting the motor leads at the junction box, and then measure each phase to ground individually to find the fault. Next, if you fire up the system and your leg depth reads exactly minus 11.0 feet, hey, don't panic. That's literally just the default PLC value before the auto-calibration saves. You just need to recalibrate from the console. Also, keep this in mind. A simple loose encoder set screw on the designated motor shaft is the classic, everyday culprit for your leg speed reading 0 while jacking. And finally, if you see an Ethernet module glowing solid red, you've got a duplicate IP or an unrecoverable fault on your hands. Recycle the power and verify your IP configuration. Now, separating a safe state from a dangerous state on the PLC is entirely visual. Solid green, that's your normal operational state. You are good to go. But a flashing red light, that is a major fault. Recycle the PLC power immediately. And, if it's still flashing after a reboot, you need to escalate that straight to Cameron technical support. I really want to emphasize this next point because ignoring this warning can literally lead to a catastrophic rig failure. If you see the amber force light on, it means inputs or outputs are being manually forced by the software. Do not, under any circumstances, attempt to jack the rig without a qualified programmer right there on site with you. Just don't do it. Finally, Section 5. Consolidation. Let's wrap up everything we've established in this explainer. Okay, so you now have a really strict reference tool for your daily troubleshooting workflows. We established that concrete baseline for your critical measurements, pulling straight from OPEU 375700 revision 04. We built a step-by-step symptom-to-cause diagnostic mindset for both mechanical and brake failures. And we mapped out those visual safety states for the electrical and PLC systems. Next time, we're going to journey even deeper into the control system architecture, looking at PLC redundancies and resistor bank phase modes. I'm going to leave you with this one high-stakes scenario. If the alarms sound tonight and multiple motors overload on a single leg, are you ready to step up and diagnose a catastrophic lubrication failure before permanent structural damage actually occurs? Keep that in mind the next time you step onto the rig. Trust your baselines, trust your workflow, and always stay curious. Thanks for joining me on The Explainer.